Good morning. Today we are going to discuss about the types of forces, stress and strain. As we know that our paper is about structural geology and all the structures are somehow related to the different forces applied on them by the tectonic activities. So let us see some type of forces and then we'll go for stress, strain and their relationship. Types of forces. Here you can see in the diagram that five fundamental types of forces are represented by the model. You can see that the first one is compression, the another one is tension, third is shear, torsion, and bending. Let us see the first. When you see that there is a rock in the earth crust, if the area is tectonically active, then due to that active tectonism, different kind of forces will be applicable on that rock strata. And on the application of these different kind of forces, the rock will develop the structures. So any among them, any force among them would be applicable on the rock. So tectonism can develop any one of these or all of these forces in the earth crust. And the resultant is the deformation. Let us see the first. Compression. Here you can see when the rock strata is compressed by both the sides, means when the force is applied in a manner to compress a rock, then in that case the force can be termed as a compressional force, and the result is the compression of that object or the rock strata. In a second picture you can see that the object is pulled apart and a tension is developed in an object. Such kind of force is called as a tensional force, where the object is pulled aparted with the help of the two equal and opposite forces, creating tension in the object or a rock mass, and because of which a tensional activity occurs. Such kind of force is called as a tensional force. Then you can see here in third diagram, we can see that there is a shear force or the shear activity. Here, the two equal and opposite forces will work away from each other, but they are not acting on a single point. They are acting on a different points. In tensional force, you can see that they are pulling apart from each other, but the force is subjected to a specific location, a specific single location. But in shear force, you can see that these two forces are apart from each other and moves away from each other. In that case, shearing happens. Such kind of force can be termed as a shearing force. The fourth one is a torsional force, where the torsion is developed when the object is rotated anti-directional to each other. In that case, there is a development of torsion in the object, and that specific force is called as a torsional force. The fifth and the last one, you can see that there is a bending force, where the object can be bent with the help of this force. You can observe the various arrows. These arrows indicates the direction of the forces. You can see in the compression and in the tension, the arrows are different. In compression, it is towards each other, whereas in tension, they are away from each other. In shear, you can see that though they are away from each other, but they are acting on different points. In torsion, you can see that the object is rotated to the anti-direction. In bending, you can see that the two forces are applied in a single direction, whereas a single force is applied in between in an opposite direction. So in that case, different kind of deformation occurs in the rock strata. So these are the forces you can usually observe in the tectonic belts where a tectonism is active. Usually, Earth is a dynamic system, and hence, in such dynamic system, when the plate moves away from each other or towards each other, the different kind of forces become active, and as a result, different kind of deformations are available. Now let us see the stress and strain concept. The types of forces and the stress and strain are strongly interrelated to each other. Stress is defined as the force experienced by the object which causes a change in the object. Means stress is a mogum term, is a general term applied to a force when it is applied on an object which causes change in the shape of the object. Like you can see that is a compressional force. You can call it as a compressional stress. In tensional case, you can call it as a tensional stress because the force is applied on the object and as a result, the object will change its shape or size. So stress is nothing but the force. It could be compressional, tensional, shear, anything. On application of it on the object changes the shape. While a strain is defined as the change in the shape of an object when stress is applied. So strain is the result of the stress. When you apply stress on the object, it changes its shape, and that change in shape is termed as strain. So stress and strain are just both interrelated, or we can also say that strain is a consequence of the stress. If you apply stress on the object, definitely as a consequence, you will get the strain in the object. So this was all about the types of forces and the stress and the strain. Stress and strain relationship. So this is a very important aspect in rock deformation studies, that how the stress and strain are interrelated. We have plotted stress and strain, and we have seen that the three different kind of deformations are available. The first is elastic deformation, the another is ductile deformation, and the last one is a brittle deformation. So what the elastic, ductile, and brittle is, and how the stress and strain are interrelated to each other. Now just consider the case where you have started increasing stress from the zero or from the origin of the plot. Slowly, when you will increase the stress, the strain will also increase. They will be exactly proportional to each other. The amount you will increase the stress, the similar amount will be seen in the strain to the point which is known as an elastic limit. This elastic limit defines that below this, if you release the stress, the object or the rock will regain its original shape and size. But if you cross this elastic limit, then you will enter in the plastic deformation or ductile deformation. Here, on the removal of stress, you will not get the exact original shape and size because there is a plastic deformation or ductile deformation in the object because you have crossed the elastic limit, and it will go up to the maximum point which is called as the fracture point or a yield point. You can see here that the column developed from elastic limit to fracture is called as a permanent strain because, as you know, if you will remove stress from the rock, you will not be able to make the strain zero because you have already crossed the elastic limit, and hence the strain developed after the elastic limit is termed as permanent strain. Now consider if you are increasing, consider that you are increasing the stress continuously. Now the stress and strain are not directly proportional. The proportionality is little distorted, and when you will increase it again and again, in a continuous manner, the point will come where the plastic limit will finish and the rock or the object will break down. That point is called as a fracture point, where the object or the rock breaks, and that breakage can be termed as a brittle deformation. So the most important thing what we will learn from this diagram is the elastic limit, plastic limit, and the fracture point. Before elastic limit, the rock can attain its original shape and size. If you cross the elastic limit, then you will not be able to regain its original shape and size, and the permanent strain will develop. And if you cross the plastic limit, the second point, then there will be a fracture. It is also called as a fracture point, where there will be a breakage and a brittle deformation can be observed. There was a technical issue. So we were on the relationship between the stress and the strain. Now you can see that a different type of deformations or different type of material are put here in the form of graph, where you can see that the different kind of material behaves differently and develops different type of graphs. Like the material which is more elastic will definitely have a higher elastic limit, and the material which is very less elastic will have a very less elastic limit and a what we can say high less capacity to behave elastically, and it will show a brittle deformation very easily. The first graph you can see that it is a brittle plastic where the material is less elastic and much more plastic in nature. Hence, on application of a stress, it will, of course, it will break down easily. Tough and strong plastic, the graph, you can see here how the graph is. Then you can see in a hard and tough plastic, where you can again see that it behaves differently with the increase in the stress. And the elastomers, where the elastic limit is very high or it is very highly elastic, it will behave again differently. So this actually the significance of this graph is to indicate or to explain that how the different material will behave differently under the effect of stress. Okay, so the rocks which we have in the earth crust will definitely have a different elastic limits depending upon its constitution, and because of which each and every rock will behave differently. Say for example, on the application of a tensile stress on any rock which is more elastic will behave differently and will develop force, say for example fold, which is a elastic or a ductile deformation. And say for example, if we apply the same force on the rock like granite or the basalt, which are more brittle in nature, they will develop the fractures or the fault along it, which is a brittle deformation. So similar kind of stress can develop different kind of deformation, which ultimately depends upon the different kind of rocks present or which rock is subjected to that stress. So this was all about the stress and strain. Thank you very much for your patience listening. And if you have any queries, you can ask me or you can put in the online medium. I've also put the remedial coaching mechanism Google link form where you can put your queries in it, and as a remediation, I will deal with them, and whatever queries or doubts you will have through those Google form, I will manage them accordingly. So thank you very much for your patience listening.